All right, welcome, folks. I'm Kevin Rader. I'm helping out Mark and Scott today, and I'm just going to introduce everybody giving their talks today in the football analytics track here. So to start, we're going to have Harold Sackrowitz give a talk. He's a professor in the statistics and biostat department at Rutgers University. He received his PhD in mathematical statistics at Columbia University, and he's going to be talking about strategy implications of the PAT rule. So Harold, take it away.
I need this. Okay, so this should, it says it's on. I don't know. Okay, that sounds good. All right, so I guess coming over here, I realized that that might be a little bit misleading. The strategy, saying strategy implications sort of implies I know what you're supposed to do, but actually the implications I was thinking of is what people should be, or teams in particular, should be thinking about, and maybe then figuring out what to do. Okay, well, this got started in 1958. The colleges decided to allow for a two-point conversion option after a touchdown. And then in 1994, the NFL did the same thing. All right, so from 1994 to 2014, what they did is after teams scored a touchdown, they put the ball on, clock is stopped. One of the nice things about trying to analyze this is what happens at the during the two-point, any point after attempt is sort of separate from the game. Okay, it doesn't impact the game except for the score. So they put the ball down on the 2-yard line, and the team could either try to kick the ball through the uprights, which is worth 1 point and the equivalent of about a 20-yard field goal, or they could try to just run it, and then they would get 2 points. Okay, so the idea, being in the entertainment industry, the idea was to keep fans interested longer, keep the outcome of the game in doubt longer. And I think it probably works, because this last Super Bowl, the Patriots were behind by 16 points, less than 10 minutes left in the game. The other team had possession of the ball, but they were still able to catch up because they made two-point conversions. Okay, the positives, the game would remain doubtful longer. Another nice thing that the NFL probably likes is that there are more controversial decisions. And then fans can fight about that. The only negative I can think of is that it gave coaches another thing to think about and be judged on, so that might even be a positive for most of us. All right, so we'll just use a little bit of notation. P1 will refer to the true probability of a successful one-point conversion. P2, true probability of a two-point conversion, and then we'll use F1, corresponding Fs, to refer to the actual observed success rates. Okay, in 1998, when I first became interested in this, the average rates in the NFL that year was 98.3% successful kicks and 38% successful two-point conversions. Okay, by 2014, the successful kick had risen to over 99%, maybe 99.3 or whatever. And you're talking about over 1,100 attempts per year. The two-point conversion rate, there were not that many, relatively speaking, so there were maybe 70 a year, and that tended to fluctuate. But in the last few years before 2014, it was up around the upper 40% to around 50%. I think there was even a year or two when it went over 50%. But because it was so variable, I guess that wasn't taken too seriously. Okay, but what the NFL did decide was that the one-point try was too automatic. and that the fans, that's after a touchdown was scored and they set up for the one-point attempt, that's when everybody went out to buy some snacks or whatever. So they felt something had to be done. Beginning with the 2015 season, they made the one-point attempt more difficult. For the 1 point, they took the ball back from the 2-yard line and set it up at the 15-yard line. So that was a 13-yard extra distance for the kick, and that became like a 33-yard field goal. The 2-point attempt, the ball was still placed at the 2-yard line. You could argue that it became slightly more difficult because one play you could no longer use was to fake a kick and then run it. Okay, now from what now since I'm somebody who looked at 2-point conversions for a while, I was pretty excited to see they were considering a rule change. Leading up to this 2015 season, there was some stuff in the papers and on TV about it, but it seemed to me that the football community wasn't that impressed. And actually the predominant feelings, so this is almost a quote from some people, from some coaches, that place kickers had become so good it wouldn't make much difference in play calling. Well, that turned out, from my mind, to be true, that it didn't make much difference in their play calling. But really the question should have been, was should it have made a difference in their play calling? So I'll show you the numbers and tell me what you think. In 2015, the 1-point conversion dropped to slightly over 94%. In 2016, it was 0.934, and so overall it was 0.938. And, well, whoops, wrong button. Okay, what happened to this? Okay. Look at the number of attempts that they made. I mean, it's pretty steady. And what I can tell you is so far in the two, I guess it's been 32 games so far this year, the rate has been essentially 0.938. Okay, they've already missed 8 extra points, and usually in 2 weeks, and in the old days, 3 years ago, it would have taken them 8 or 9 weeks to get that many misses. The 2-point success rate also was remarkably steady. And that was going to be a large part of this talk until the first 2 weeks, when for some reason these guys couldn't get the ball across the goal line. So, okay, well, let me just, because this is just what they should be thinking. Mathematically, definitely a key issue, or maybe the key issue, is the expected value of a 1-point attempt, which is P1, and the expected value of a 2-point attempt, which would be 2 times P2. If the 1-point attempt is worth more in expected value, then if the game was an infinite horizon game, or if you simply wanted to maximize your expected number of points, you would always just kick for 1 point. You would always try 1 point. If the 2-point was worth more, then again, you should, if you wanted to just maximize the expected number of points, you just always go for 2. Okay, now, unfortunately, maximizing the expected number of points is not the same as maximizing the probability of winning. So you really need to have some attempt at computing actual probabilities that you think are appropriate. Now this will be one of my later implications. Historically, before 2015, when people or papers, the reporters talked about point after attempts, they always kind of assumed that the expected value of a 1 point was worth more than a 2 point, even though in some years the rates didn't show that. All right, so what we need to do for an optimal strategy chart is it should tell you look at the score differential, ideally look at how much time is left in the game, and try to give you a decision or an action to take. Okay, now one of the things I liked about this is you cannot fully answer this question empirically. Okay, these situations do not come up often enough that you can accumulate data to tell you what to do. And not only don't they come up often enough, but even you're not going to get coaches to say, okay, I just scored a touchdown, I'm losing by 2 points with 17 minutes left in the game. Should I go for 1 or 2? Maybe I'll go for 1 this time, and the next time that happens, I'll go for 2. And so after I've done this 50 times each, I'll have a sense of what really works. So that's not going to happen. So you really need to try to compute probabilities. So before I compute probabilities, I'll tell you that that's not really possible. There are just too many unknown quantities, and you can't really estimate those quantities in a reasonable fashion. What you can do is build a model of a game that kind of looks like football. You're hoping that it's close to football. And for that kind of game with particular values, you can compute probabilities. When you look at how they behave for that model, you're hoping it would behave the same way, and it seems reasonable it would behave in a similar way to the real game. Okay, so what I did is first, I chose a moderately simple model. And you have 2 teams or 2 players, and they alternate possession of the ball. And I measured time in number of possessions. Because every instance that I've seen reported where a person is able to get a coach to comment on how he made his decision, it kind of starts off with, well, I thought they would have maybe 3 more possessions, or we would have. They sort of think in terms of how many possessions and what can happen in those possessions. All right, so what I did was I measured in possessions, and then for each team, I supposed that I knew the rate at which they scored field goals, the rate at which they scored touchdowns, their 1-point conversion success rate, their 2-point conversion success rate. And I just say, if I know all of that, I will be able to compute the probabilities for you. So, but of course I don't know that. So I was thinking of those as being initial conditions. Okay, well, this is a wordy slide. I did this in 2000. I wrote a paper for Chance that gives the equations and everything that you need to do to solve this using dynamic programming. Dynamic programming starts at the end of the game and works its way forward. And it's extremely flexible. I can talk about later what it can do. All right, but to get an idea of whether it's worth anything, this is what I did. Well, actually, what I'm going to show you is what happens for 3 collections of initial conditions. I mean, when I was doing it, I did lots and lots of them. It's kind of a good time waster. Okay, so initial conditions set A. P1 is 99%. P2 is 42%. Conditions A and B both have P1 equal to 99, and that's how it used to be before 2015. Okay, 42% in these days is a pretty low success rate. 47% is an okay success rate. I also changed in the initial conditions A, I'm using, where is it? Whoops. I'm really weak on this. Where is the thing? Oh, okay. So 13% of the time they score field goals, 21% of the possessions they could score touchdowns. In this one, it's 19 and 30. So those two are pretty different in terms of initial conditions. The last one, I just used the numbers from 2015, 2016. Okay, so what do you get? All right, so I put these up piecemeal so that it's important to be able to see these numbers. What I did is let me go back. I did conditions A and conditions B, computed the probabilities, and then based on that, constructed the strategy table. Then for this, I superimposed the first two, the conditions A and the conditions B on the same picture. Okay, so here's condition B. If you are behind by this number of points, and there are a total of this number of possessions left in the game, the only difference where I have a star, okay, without the star, it would be conditions A. With the star, it's with conditions B. So these stars are the only places where, with fairly different sets of initial conditions, that's the only places that they're different. And this is from behind. This is when you're behind. This is when you're ahead. When you're ahead, it's here and in here. So, in terms of usefulness, I would say that it cannot tell you what to do in all situations. But if you're up in here, for example, and I wouldn't even go to the edge. If you're over here, I can't even, what am I lined up with, 5? Okay, if you are ahead by 5, I would go for 2 anytime in here. And look when this starts. A game has approximately 5 to 6 possessions per quarter. So even if you're being generous, by the second half, you should be going for 2. Okay, if you're over here, if you're on the boundary, I might not know. If I see this, I might not know. But if a team were to generate a whole lot of these charts for various initial conditions, they get an idea of when they can confidently do something and when it's the coach's gut decision. Okay, now notice that this is sort of dominated by 1s. And that's because, as has been thought a long time, 1 is the default. Okay, just kick, that's the default condition. All right, now let's take a look at what happens these last 2 years. Okay. This is what this table looks like if you use the conditions, the probability of success rates in the last 2 years. Now this thing is dominated by 2s. Okay, you could almost say that 2 is the default condition. And here's one that's interesting. If you are ahead by 6, I hope this is the right line. If you're ahead by 6 with 20 possessions remaining, so it's early in the game, you just scored, you have 6 points, you're winning 6-0, that thing would go for 2. Because this game still looks like it might be an infinitely long game. And if you're playing a game with no horizon, the 2-point attempt is worth more than the 1-point attempt. All right, so this is when you're ahead. When you're behind, again, there are twos. Well, when you're behind, you're going for two almost every single try. Except over here, I don't know the answer to that. Now, what I am convinced of is that's the most important spot in the whole table. And it has nothing to do with what the rules are. I mean, it has to do with the probability of success, but it has nothing to do with the rules, whether it's, this is going to come up. You are going to have, okay, we have just scored a touchdown. We're behind by 1 point, and there's only one possession remaining in the game. Okay. All right, so here's my technical contribution. All right, so to figure this out, regardless of whether we go for 1 or 2, and regardless of whether we make it or don't make it, we are going to lose this game if our opponent scores during that last possession. A field goal will win, a touchdown will win. So here, what should we be thinking? All right, so if we go for 1, then we win if P1 we make the point. Then our opponent does not score, and then assuming and winning in overtime is a half, say. If we go for 2, the probability we win is, again, P2 making the 2, and then our opponent doesn't score. So it looks like basically you have to compare this, a half P1 with P2, or P1 with 2P2, and P1 is the expected value of a 1 point, 2P2 is the expected value of a 2 point. So that seems simple enough, but if I'm cheating, okay, because these two, although taken out of context is a correct statement, and taken out of context, that's a correct statement, but if you put them side by side, that's not right anymore. Because, well, we need to compare these two, but the probability, in one case, it's the probability that your opponent will not score if the score is tied. Okay, so this is the last possession. So your opponent is guaranteed, if he's careful, going into overtime. If he's behind by 1, then this is desperation time. This is 4-down football, and 4-down football, you're going to score more often. Okay, you wouldn't do this during a game because if you're intercepted or whatever, it's a turnover, all sorts of bad things can happen. But in that last possession, if you're behind by 1, you're going to take chances that you wouldn't ordinarily. Okay, so you have to know. Where is it? Okay, so you have to know that, and that's equivalent to comparing the expected value of a 1 point divided by expected value of a 2 point, and you have to compare that with Q1 over Q0, where Q1 is the probability that your opponent will not score if they are behind by 1. And Q0 is the probability that they will not score if the game is tied. Okay, so this, Q0 is always bigger than Q1, so this is always less than 1. Before 2015, the value of a 1 point was worth more than a 2 point. So before 2015, everyone clearly felt that that was bigger than 1. And this is less than 1. And so there'd never be an issue. prior to 2015. But in 2015, and I don't know what the actual values are, but in 2015, that ratio, observed ratio, was 0.947. To make you want to go for 2, you have to get this left-hand side to be less than 0.947. Okay, so you need this to be less than 0.947, which means that you need by, if that ratio goes down by more than 5%, it's approximately 5%, then you'd better not go for 2, you better go for 1. And so, the reason I had a question mark there is because I haven't a clue as to what Q1 and Q0 are. So one implication is that teams should figure this out. Because the data, there is a lot of data around, because this has nothing to do with what the point after attempt rules were. Over the years, for years and years and years, even before, it hasn't even nothing to do with two-point conversions. To get these numbers, that has to do with, it's the end of the game. You look at how much time is left, and then you see how often a team that was behind by 1 was able to score, and how many times when it was tied where they were able to score. That has nothing to do with anything. So there's got to be a lot of data involved in there. Okay, so let's just last year alone, in the first week, okay, so the Oakland Raiders scored a touchdown, and they were behind to the Saints 34-33, 47 seconds left to go in the game. They went for 2, and they won. The Kansas City Chiefs, okay, they scored a touchdown. They're behind to the San Diego Chargers 27-26, 67 seconds remaining in the game. They go for 1, and they win 33-27. Carolina Panthers, this is the last game of the season. Carolina Panthers scored a touchdown. They're behind 17-16 with 17 seconds remaining in the game. They go for 2, and they lose. The question is, who was right, who was wrong? Were they all right? Was anybody? And to me, based on what I had before, I'd say, if anything, the last one, the Panthers were right, because there were only 17 seconds left, but they lost. The Kansas City Chiefs, they probably did the right thing. Oakland Raiders, I'm not so sure. But none of these coaches, when they're asked about it, say, well, that was the percentage play or whatever. They'll say, well, I can tell you what the last guy said. Okay, so the reason he went for 2 is because he came to win. Okay, he said, we came here to win. Okay. So I guess not all coaches do that, but fine. Let's see. I guess, okay. All right, let me just say, the thing that truly messed me up, these last 2 weeks, the percentage of two-point conversions went down to about 48.5% from 49.5%. So if I run the table again, this much of the table, wherever there's red, that constitutes a change. And so now you can see if you're ahead by, where is it? If you're ahead by 6 early in the game, you just scored a touchdown, you're ahead 6-0. Now you wouldn't do it. So you have to think. Because I think that with the current rules, it's possible that the question that used to be, when should we go for 2, has changed to a question, when should we go for 1? Okay. Usually my family and friends don't last as long as you did when I start talking about this, so thank you.
Cool. Thank you.
Thank you.
Cool. Thanks, Harold.